This last section on lines that we're going to talk about deals with two very particular types of lines. They are parallel and perpendicular lines. So we're going to start by talking about parallel lines. And you can see here that we could define parallel lines as two non-vertical lines. They're going to be parallel if and only if their slopes are equal and they have different y-intercepts. In other words, they're going to cross the axis, the y-axis, at different spots, but yet their slopes are exactly the same. And there's another statement here saying, okay, well, if I have parallel lines, they don't exactly cross the y-intercept, but they would have different x-intercepts. But you can see from these pictures here that these would be parallel lines. The key to parallel lines are that they have slopes are equal. Okay? Now, if we wanted to determine whether or not two lines were parallel, we have some steps we want to go through. First, we want to make sure that our equations are in the slope-intercept form. In other words, we want them to be y equals mx plus b so that we can look at the slope. Remember, we're looking to see that slopes are the same. The next step would be to determine the slope and the intercept of each line. And if the slopes are the same and the intercepts but the intercepts are different, then we can say that the lines are parallel. So let's practice with this first example here. I have the first line. I just put a 1 down here so we'd know that this is the line 1. It is written as y1 y is equal to 4x minus 5. And my second line is y is equal to 3x minus 2. Well, since my line is already in the y-intercept form, y equals mx plus b, I'm going to move on to the step number 2, which says to determine the slope and the intercept. Okay, so my slope for this first one, m1, is equal to 4, and my intercept, b1, is equal to negative 5. On the second line, we'll call this m2, the slope of the second line. My slope is 3, and my intercept is equal to negative 2. So, if I'm supposed to be determining whether they're parallel, I'm going to look at their slopes first. Are the slopes the same? The first slope is 4, the second slope is 3, so therefore these are, 3 little dots mean therefore these are not parallel because their slopes did not equal. Alright, let's practice again. This second example has two lines, 2x minus y equals 5 and negative 4x plus 2y equals 7. Our first step tells us that we need to put our equations in the y-intercept or the slope-intercept form. So let's do that first. Okay, so I am going to subtract 2x from both sides. Remember, I get negative y is equal to negative 2x plus 5. From here, I need to divide by a negative 1. And I will end up with y is equal to positive 2x minus 5. Now let's come over here and do that to the second equation. I'm going to add 4x to both sides. I end up with 2y is equal to 4x plus 7. Divide both sides by 2, and I get 2x plus 7 halves. Okay, so step number 2 tells me to determine the slope and the intercept. So the slope of this first equation is 2, and the intercept is negative 5. The slope of this second equation, this is looking good, is also 2, and the intercept is positive 7 halves. So step number 3 says, okay, I need to decide whether my slopes are equal, and here I can see that m1 is equal to m2 because 2 is equal to 2, and b1 does not equal b2. Remember, we don't want them to be crossing at the same point on the y-axis, or otherwise they would be the same line. So b1 is negative 5 and b2 is 7/2. So those are not equal, so we can say that therefore these lines are parallel. Okay?